All right, this video is going to explain to you how to do a free body diagram. As we go through this, these are going to work through the first 3 problems of your worksheet as well. Remember, at any point you can pause, rewind, or do whatever you need in order to catch everything that you see in the video. So a couple things to start with. First of all, there's some rules that you need to keep in mind. And you're going to see these are going to appear on a lot of the stuff that we do so that you can start to kind of make it a habit of looking at this stuff. So first of all, and obviously one of the more obvious ones, it's going to be always read the question first. So if we look down here, I provided an example of a question. It says, a notebook is on a desk. The force of the notebook, weight, pushing down on the table is 10 newtons. The force of the table, normal force, pushing back up on the notebook is 10 newtons. Draw the free body diagram and calculate the net force. Okay, so the very first step you're going to do is you're going to draw a square. So I'm just going to put a square here right in the middle, and you should do the same on your paper. Now, we need to diagram the different things that are happening in regards to the story. So I'm going to move this over a little bit. One of the first things that it says is it says the force of the notebook or weight pushing down is 10 newtons. So we need to think about the different types of forces that we learned about, and one of the types of forces that we said pulls down is going to be gravity. So I'm just going to draw a vector coming out of the bottom there. Okay. Please notice that the arrow is pointing down. You never want to show an arrow pointing towards a box. That's a no-no. So we always want it to be coming out of the box. So think of this box as the object we're talking about. So in this case, the notebook, and this vector is representing this first part that I highlighted. Now we always have to label it with 2 things. So we need to label it with the type of force. Well, we just said the type of force is going to be gravity, okay, the weight that's pushing it down. So on our notes we learned that we're going to label it F grav, and I'm going to put that there. And then we also need to label it with the amount of newtons, which is given to us in the story, which is 10 newtons. So I'm just going to also add 10 newtons. Okay, so I've labeled my vector. Now the next part of the story says the force of the table, normal force, pushing back up on the notebook is 10 newtons. So I'm going to highlight this so I remember what I'm looking at. Okay, so I need to draw my vector coming out of the box. Okay, and normal force I know pushes up. Now a couple things I want you to notice. First of all, because it's the same amount of newtons for both of these, I really want to try to make sure the vector is as close to the same size as possible. So I know it's not going to be exact, but you just don't want, for example, you don't want a vector like this. Okay, it's very obvious that those 2 are not the same. So since these both are 10 newtons, we want to make sure that they look as similar as possible to one another. I'm going to say about there. Now, same idea. First of all, I need to label it with the type of force. Okay, and they said in the story it says normal force, so that's F norm. And then I need to label it with the amount of newtons as well, which once again is 10 newtons. So I have everything checked up on here, 1 through 5. I drew a square. I drew my vectors coming out of the box. I knew that one was gravity and one was normal force, so I labeled them. And I also included the amount of newtons from there. Now it's just like any of the ones that we did before, trying to calculate the net force. So I have 2 vectors going in opposite directions. Okay, it's 10 newtons and 10 newtons. So when you have 2 vectors going in opposite directions, you subtract. And when I subtract that, I get 0 newtons. And it's not going up or down because it is 0. It's balanced. So I'm just going to go ahead and leave my problem as that. So the net force for this problem is 0 newtons. So this would be everything that you would be required to do. Okay, let's try another one. All right, so now we're going to work on practice problem number 2. It says a car is traveling west with a force of 200 newtons and collides with another car that is traveling east with a force of 75 newtons. What is the net force? Okay, so not only do I have to find the net force, but I need to draw my free body diagram. So first of all, if I'm looking at this, I read the entire question, so that's done. Now it says I need to draw a box. So I'm going to go ahead and draw my little square. Okay, it doesn't need to be very big. I'm going to move it over here a little bit. All right, the first step it says is the car is traveling west with a force of 200 newtons. So that tells me if I am to think about a compass, I'm going to just go over here. And if I were to label this, we have north, east, south, and west. And I want to illustrate that the car is moving to the west. So that means to the left. So I'm going to draw a vector coming out of the box, not pointing towards. Okay, and it's 200 newtons, so I'm going to draw it pretty long. So if I go look at this, I drew the box. Show direction and strength of force is acting by drawing an arrow. So I have 200 newtons to the left, and now I need to make sure I label it. So if a car is just traveling, just driving, there were 4 different types of forces that we learned about. We had applied force, we had friction force, we had normal force, and we had gravity force. I'm just going to list those over here. So now if I look at those, the one that makes sense for a car just driving is going to be an applied force. So an applied force is a push or pull, but it doesn't always have to be just a push or pull. Anything that's initiating that motion. So I'm going to go over here and I'm going to label applied force. Now I also need to include by how many newtons, and it is 200 newtons. So I know that this vector represents applied force 200 newtons and it's to the left, it's to the west. Now I need to do the second part, and it says it collides with another car traveling east with a force of 75 newtons. So I'm going to draw a vector. Again, I need to visibly see that this is smaller than this because this one's representing 75 and this one's representing 200. So I need to see that there's a difference between the two. I then am going to go ahead and label. Again, it's a car moving, so I'm going to put applied force. And now this one's 75 newtons. So I have that labeled as well. Okay, and you can put these above, below the 9. You can put one on top and one part on the bottom. It doesn't matter. You just need to make sure that you have everything labeled. So if I go look up here, I showed the direction and the strength. I named the forces. Now I just need to calculate the net force. So when I look at this, I have 2 vectors going in opposite directions. So that means I have to subtract. When I subtract that, I get 125 newtons. And then finally, I need to include which direction the cars are going. So when they collide, because this number is larger, that means that it is going to the left. And that's your final net force. So for your answer, you have 125 newtons to the left. All right, the last one we're going to go over is just one, same idea, only now we're just adding a little bit more. And this will be pretty close to normal, what you can expect in 8th grade, just because it has multiple directions. So a couple things. I'm going to list over here on the side the different types of force. I have applied force, friction force, gravity force, and normal force. And now let's read the question. It says, Owen has decided to pick up the hobby of roller skating. He is moving to the left with a force of 30 newtons. Normal force and gravity are 15 newtons each. The force of friction from the ground is 5 newtons. what is the net force? So I read the question. The next thing I want to make sure that I do is I need to draw a box. So I'm going to draw a little square in the middle. Okay, so now I need to label and draw all of the vectors. So I'm just going to start, I'm going to highlight as I go. So I'm going to start here, moving to the left with a force of 30 newtons. So I'm going to draw my vector to the left. And then now I need to label it. So if he's just moving, if he's just roller skating and he's moving along, that is going to be applied force. So I'm going to go ahead and label that F app. And then it says 30 newtons, so I'm going to make sure I label that 30 newtons. Okay, so I'm just going to highlight this so that you can see what each part's going with. All right, the next part, it says normal force and gravity are 15 newtons each. So gravity I'm going to start with always pulls us down. So I'm going to draw a vector down. And now I'm going to label it. That's F grav, and it's 15 newtons. Now, normal force is pushing up. Normal force is always opposite of gravity. Okay, we don't fall all the way through the ground because we have normal force holding us up. So I'm going to draw a vector, try to make it as close to the same size as possible. Might not be absolutely perfect. Okay, and now I'm going to do the same and label it. So this one up here is normal. And again, 15 newtons is the same. So I got this from the green part of the story. Finally, it says the force of friction from the ground is 5 newtons. So that's the last part that I need to do on my free body diagram. And this is where some students get confused. Just because friction is coming from the ground doesn't mean you want to point it towards the ground. You want to think whichever direction something's moving, friction's going to be the opposite way. So if your pencil's rolling across the table this way, friction's trying to stop it, so it's pushing the opposite way. So just remember that friction and applied force are always opposites of each other. So if the applied force, if Owen is trying to roller skate this way, friction's going to be the opposite way. Okay, and it's only 5 newtons, so I'm going to make this very tiny. And then I need to label it. So on my thing up here, it's going to get a little bit close, but we're going to label it F friction, and then it is 5 newtons. And I'm just going to kind of fill that in as close as possible. You should hopefully have a little bit more room on your paper, but that's where that came from. So now we just have a vector diagram or a free body diagram that has all 4 motions going on. So now to find the net force, first look in opposites. So for example, if I were to look up and down first, I have 2 vectors going in opposite directions, so that means I need to subtract. When I subtract 15 minus 15, I get 0 newtons. So what that means is when Owen is roller skating, he's not going up or down. Okay, he's staying on the surface. So he's not falling to the ground, he's not flying up in the sky, he's simply balanced. So since it's 0 newtons there, I don't really need to identify that. Now I need to go left to right and look at these 2. Again, going in opposite directions, so I need to subtract. You have 30 minus 5, which is going to give us 25. So I'm going to put 25 newtons. And finally, I need to identify the direction that he's going. Well, the bigger number is over here, so that's the direction it is. So I'm going to draw my vector to the left, and that is going to be your net force.